The following are the specifications for the digital copier DP6570 or 5570. Resolution is 600 dpi by 600 dpi for scanning and 2400 dpi by 600 dpi for printing. The acceptable copy size is A3 to A5R or ledger to statement R. The copying speed is 65 copies per minute for the DP6570 and 55 copies per minute for the DP5570. This table shows you the details. The scanning speed is 65 scans per minute. The first copy time is 3.6 seconds. The warm-up time is about 420 seconds. The maximum paper capacity for all sizes combined is 5,600 sheets. The reproduction ratio is 25% to 400%. The PM cycle is every 400,000 copies for the DP6570 and 340,000 copies for the DP5570. The memory capacity is as follows. This is a further breakdown for the hard disk drive unit. The storage capacity is as follows. Toshiba's original encoding technique, the Rector algorithm, is used for encoding image data. The Reversal Automatic Document Feeder, RADF, comes as a standard feature. It has a transporting speed of 65 sheets per minute and allows up to 60 sheets to be loaded at a time. The First In, First Out, or FIFO system automatic duplexing unit, ADU, also comes as a standard feature. It has a transporting speed of 65 sheets per minute and allows up to 60 sheets to be stacked. In addition, the Large Capacity Feeder, LCF, with a paper feed capacity of 4,000 sheets, also comes as a standard feature. Next is a general overview of the product. First, let's talk about supplies. Drum, OD6570. Developer material, D6570. Toner, T6570 or T6570E. Toner box, TB6550 or TB6550E. Convenient replacement units for maintenance or user replacement units are available. Cleaner unit. Developer unit. Main charger unit. Belt transport unit. Fuser unit. Next, let's talk about the options. For the finishers, a 2-bin finisher, the MJ1006, which allows multiple stapling, and the MJ1007, which has a stitching function, as well as the multiple stapling function, are available. In addition, the work tray KK6570, the damp heater kit MF6570U or MF6570E, and the key copy counter MU8 or MU10 are available as options for the standalone type. Next, let's talk about options for extending the system. With the LAN printer unit KR7016 or KR7016E, the DP6570 or 5570 can serve as a network printer. In this case, select one of the 3 network interface cards, NICs, KR7017, KR7018, or KR7019, depending on your network type. Installation of the NIC allows the copier to operate as a network printer. The KR7017 is designed for a 10 base T or 100 base T network, KR7018 for a 10 base 2 network, and KR7019 for a token ring network. In addition, the extension memory DIMM dual inline memory module KR7020 can be installed into the printer unit. The memory capacity of the DIMM is 32 megabytes. In order to upgrade the DP6570 or 5570 to a document solution system, an interface board with a DSS controller, the KR8003, is available for installing the controller to the copier. Next, we will explain about the service jigs. The door switch jig allows you to service the copier with the front doors open. The wire holder jig is used to attach the carriage drive wire smoothly. The lens adjustment jig is used to prevent the lens unit from tilting when adjusting the lens reproduction ratio. The FROM adapter jig is used to write firmware data in the flash ROM. The application of the screw lock paint prevents the adjustment screws from becoming loose. In addition, the FSMS Field Service Management System is available as a service tool. It allows FROM data to be rewritten directly by downloading firmware data from a PC. Next, we will explain the special functions of the DP6570 or 5570. Dual page copying, image shift, edge erase, FIFO system duplexing, XY zoom, trimming, masking, mirror image, negative positive reversal, annotation, page number, alternation, magazine sort, two-in-one, four-in-one, document storage. The document storage function works in the memory mode or print mode. 24 IDs can be registered, and up to 100 pages can be stored per registered ID. Cover sheet. Sheet insertion. In addition, in the Access Control mode, which requires users to enter a 4-digit ID code to make copies, 120 IDs can be registered. The Auto Job Start function permits a job to be set during the warm-up time and starts copying automatically once the copier is ready. The Job Preset function permits another job to be set while printing is being performed after the original scanning, and starts copying automatically following the previous print job. The weekly timer function allows a weekly time to be set that turns the copier on or off. In the mode memory function, combinations of frequently used copy modes can be stored and be recalled whenever necessary. Up to 4 combinations can be stored. The language on the display panel can be changed with a one-touch operation. First, we will talk about the specifications and then give a general overview. First, let's look at the unpacking and setup for the DP6570 digital copier. The copier must be unpacked by 3 service technicians. Cut the straps and remove the upper part of the carton. Take out the rails, the drum, and the accessories. Then check the accessories. 2 rails, 2 blind covers, drum, drum cover, original feed tray, operator's manual, operator's manual pocket. Inlet type power cables are included for the ASD, AUD, and MJD. 2 types of power cables are included only for the MJD as shown. Peel off the 2 pieces of adhesive tape fixing the lower part of the carton. And then open the carton. Do the same thing on the other side. Turn the centers of the 2 fasteners counterclockwise to open, remove them, and then remove the outsides of the fasteners from the carton. Open the main carton and remove it. Remove the packing material from each corner, and then take out the carton for the accessories. Remove the packing material from under the bottom of the copier on the rear side. The copier must be lifted up a little by 2 people holding the grips at the bottom of the paper feed side, and a 3rd person must remove the packing material from under the paper feed side. Do the same thing to remove the packing material on the paper exit side. Then remove the packing material from under the paper feed side and from under the paper exit side. Completely roll down the plastic cover. Firmly hook the protrusions of the 2 rails into the grooves of the platform and align the rails with the rail positions on the platform. The copier should be slid down from the platform gently by 2 people. Make sure that the copier is slid on the rails. Then open the RADF and remove the 2 packing sheets. Remove the 2 screws and detach the glass holder. Remove the 4 screws fixing the carriages. And then attach the glass holder and the 2 blind covers provided. Draw out the lower cassette and remove the packing material. Do the same thing for the middle and upper cassettes. Peel off the 3 pieces of adhesive tape. Then peel off the adhesive tape fastening the finisher connector cover. Open the door of the LCF and remove the packing material. Open the front doors on both sides and remove the packing material from the left front door and from the LCF, respectively. Remove the 4 packing screws. Turn the handle counterclockwise and withdraw the belt transport unit toward the front. Turn up the jam release unit and remove the 2 screws securing the pressure levers of the fuser unit. Insert the belt transport unit. Loosen the 3 screws fully and take out the middle inner cover. Remove the packing material. Remove the connector. Turn up the lever to release and draw out the developer unit halfway. Remove the packing material from under the developer unit and detach the developer unit. Loosen the screw fully and withdraw the main charger. Remove the connector. Loosen the 2 screws fully. Take out the cleaner unit and place it on a level surface. Remove the fixing screw of the main blade. Take out the connector. Remove the screw and detach the drum thermistor. Remove the 2 screws and detach the drum shaft. Put the patting powder on the drum separation claws. At this time, please make sure that there is no patting powder adhered on the toner adhesion amount sensor. Put the patting powder on the entire drum surface. Face the gear of the drum toward the rear of the cleaner unit and set the drum shaft. Then fix it with the 2 screws. Turn the cam of the main blade clockwise and turn the drum flange. Repeat this action 2 or 3 times so that the drum can make smoother contact with the main blade. Attach the drum thermistor with the screw and the connector. Attach the cleaner unit by aligning it with the guides of the copier. Fix it with the 2 screws and set the connector. Set the main charger. And fix it with the screw. Remove the lid on the top cover of the developer unit. Shake the developer material bottle well, and then pour the material into the developer unit. Mount the lid on the top cover firmly. Shake the developer unit gently to level the developer material. Then rotate the magnetic roller drive gear in the direction indicated by the arrow and confirm that the developer material conveys evenly. Attach the developer unit to the copier. Push down the lever to fix it in place. And set the connector. Mount the middle inner cover with the 3 screws. Turn the handle of the belt transport unit clockwise and close the front doors on both sides. Peel off the adhesive tape on the reverse side of the original feed tray and fix it with the 2 screws temporarily. Loosen the 4 nuts securing the 4 adjusters of the copier. And move up the caster by turning the adjusters. Then place the water level on the original glass. Adjust the adjusters to make the bubble come to the center of the water level. And finally, tighten the nuts. Attach the operator's manual pocket and put the operator's manual in it. Connect the power cable to the copier and plug it in. Load paper in each cassette and close all cassettes. Turn on the main switch and lower the LCF tray. Then open the LCF door, load paper in the LCF, and close the door. Turn off the main switch, and then, while pressing the 0 and 5 keys simultaneously, turn it on again. Key in 200 and press the Start key, and the copier will start operating. The toner sensor output value will be shown on the message display. In about 2 minutes, the value on the message display will start changing. After that, the value will stabilize and Adjust Mode will be shown. At this time, confirm that the value is in the range between 245 and 255. If it is not within this range, adjust it using the up and down icons. And then press the Set icon or Interrupt key. Press the 0 and 9 keys at the same time, and after a while, Ready will be shown. Shake the toner cartridge up and down and from side to side at least 10 times. Open the toner supply cover. Hook the toner bottle in place. And then fully withdraw the slide lever. Tap the toner bottle. Return the slide lever. Remove the toner bottle. And then close the toner supply cover. Set the test chart, make a copy, and confirm the following. Confirm that multi-copying from each cassette and the LCF and sheet bypass copying are functioning properly. Make sure that there is no problem with fixing and cleaning. Make sure that there is no overexposure or underexposure. Make sure that there is no problem with the displays on the control panel and the keys. Next, set the time. Press the Program icon on the touch screen panel and then press the Date Time icon. Enter numeric values for the year, month, date, day code, hour, and minute. Codes 1 to 7 are assigned for Sunday to Saturday as the day codes. Key in all values and then press the Set icon. Accurately draw lines lengthwise and widthwise in the center of a sheet of paper and use this original as the test chart. Place the test chart with the original side face up on the original feed tray and adjust the side guides. Press the Start key and make a single-sided copy from the RADF. The copy should not be skewed. The line of paper movement direction should be in the center of the copy, and the copy image should have a proper top margin. Be sure to check these 3 points. If it is skewed, loosen the 2 hinge fixing screws. Continue to adjust the right hinge until the copied paper is no longer skewed. After adjusting, firmly tighten the screws securing the hinges. If the copy center line is misaligned with the paper center, loosen the fixing screws of the original feed tray and move the tray front to rear until the copy center line is aligned with the paper center. After the adjustment, firmly tighten the screws securing the original feed tray. If registration adjustment needs to be made, turn off the main switch. While pressing the 0 and 5 keys at the same time, turn on the main switch. Key in 350, press the Start key, and the current setting value will be displayed on the control panel. To increase the margin, key in a number greater than the displayed value. To decrease the margin, key in a number less than the displayed value and press the Set icon or Interrupt key. An adjustment value can be set in increments of about 1 millimeter. Place the test chart on the original feed tray, adjust the side guide, and press the Energy Saver key to check the copy. Return the copier to the normal mode. Place the test chart with the original side face down on the original feed tray. Then make a duplex copy from the ADF. If registration adjustment needs to be made in duplex copying, return to the 05 adjustment mode and make the adjustment using code 351. After servicing, be sure to turn the main switch off and then on again. That completes unpacking and setup for the DP6570. Now we'll explain the unpacking and setup for the MJ1007 finisher. First, disconnect the copier power cable. Cut the straps, lift the carton box away, and take out the accessory unit. Take out the 4 pieces of packing material holding the finisher. Lift up the lower part of the finisher a little, removing the packing material, and put down the finisher gently. Remove the packing material from the other side too. Then take the finisher off the platform and remove the plastic cover. Remove the 2 pieces of adhesive tape securing the top cover. Open the top cover and remove the 3 pieces of packing material. Remove the 2 pieces of packing material from the entrance side. Peel off the tape securing the cable and the other piece of tape. Remove the cushion material from the paper exit side and peel off the adhesive tape. Peel off the 4 pieces of adhesive tape. Then remove the 3 pieces of adhesive tape and the packing material from the saddle stitcher. Peel off the 4 pieces of adhesive tape. Open the stapler cover and remove the adhesive tape and the 2 cushions. Open the stitcher cover. Peel off the adhesive tape. Draw out the stitcher unit. Peel off the adhesive packing tape. And detach the packing bracket by removing the screw. Remove the 4 screws and detach the lower PC board cover. Remove the screws and detach the packing brackets from both the front and rear sides. With the 4 screws, mount the lower PC board cover. Now check the accessories. Latch receiving bracket and 2 screws. 2 trays and 2 screws for each tray. 1 large harness cover and 1 small harness cover. Connecting rail. Rail attachment plate and 2 screws. Rail fixing screw. Interface PC board. Lock support and label. Remove the 2 screws of the upper exit cover and mount the latch receiving bracket with the 2 screws provided. Set the lower tray so as to hook the claws of the tray into the holes firmly. Set the upper tray in the same way. Secure the trays with the 2 screws respectively. Plug the connector into each tray. Hook the 2 claws of the lower harness cover in place and mount it. Do the same thing to attach the upper harness cover. Insert the connecting rail halfway under the PFP, fitting the sorter attachment plate so that the left edge of the rail goes between the sorter attachment plate rollers, and ensure that it is inserted straight under the PFP. Hook the rail attachment plate into the copier and then secure it with 2 screws. Place the opposite side of the connecting rail on the finisher and secure it with 1 screw. Remove 8 screws and the rear cover. Insert the lock support into the LGC board. Detach the harness from the harness clamp and plug the connector into the interface PC board. Mounted by aligning it with the lock support and connector. With the 8 screws, mount the rear cover. Attach the finisher to the copier, making sure that the copier and the finisher are parallel. Remove the connector cover and connect the finisher connector to the copier. Paying attention to the direction, stick the label on the original feed tray. Make sure that the finisher operates normally. That completes unpacking and setup for the DP6570 and its option MJ1007. Now we will explain unpacking and setup for the DP6570 Toshiba digital copier and its option MJ1007. Now we'll explain about the copying process of the DP6570. The copying process consists of charging, original scanning, image processing, laser exposure scanning, development, transfer and separation, fixing, cleaning, and discharge. While charging, the 0.06 mm diameter tungsten oxide wire is biased at about -6 kilovolts, and the charger grid is biased at -720 volts. As a result, by applying a charge to the surface of the photosensitive drum evenly, the electrical potential of the surface becomes -650 volts. An OPC drum with a diameter of 100 millimeters is used. In original scanning, the light irradiated to the original is reflected. The reflected light corresponding to the density of the original is projected to a CCD, or charged coupled device, via the mirror or lens. If light is directed at a white area of the original, more intensive light is reflected. If light is directed at a gray area of the original, less intensive light is reflected. And if light is directed at a black area of the original, almost no light is reflected. Then a charge is generated in the CCD corresponding to the intensity of the light. This signal is converted into a digital signal and sent to the image processing section. In the image processing section, corrections are made, or some editing processes are conducted to provide appropriate image quality. Then the image signal is finally sent to the laser exposure scanning process. In the laser exposure scanning process, the laser diode is turned either on or off, depending on the image signal. At this time, the electrical potential of the drum surface at which the laser beam is directed gets close to 0 volts, and the potential of the drum surface at which the laser beam is not directed remains at minus 650 volts. As a result, a latent image, which cannot be seen directly by the human eye, is formed on the drum surface. In the development process, the negatively charged toner and the positively charged carrier, which were mixed in the developer unit, are transported and gently brushed onto the drum surface by the magnetic roller. In laser exposure scanning, the electrical potential of the drum surface, which is exposed by the laser beam, becomes lower than the developer bias, which is minus 400 volts. So negatively charged toner adheres to the drum. 1.5 kilovolts AC at 6 kilohertz is superimposed on the developer bias, and generated electrical vibrations enhance the development efficiency. Since the electrical potential of the drum surface which wasn't exposed is more highly negative than the developer bias, negatively charged toner does not adhere to the drum. Since the charging polarity is the same as the toner sticks on the exposed part. This is called the reversal development method. Since this method is beneficial for laser exposure scanning and provides longer life for the laser diode, it is used for most of the digital copiers. Since the drum and developer are driven separately, the magnetic roller and developer bias are turned off before the charging output is turned on, to prevent the unwanted toner from adhering to the drum. In the transfer and separation process, voltage of about 2 to 4 kilovolts is applied to the flat rubber transfer belt coated with a conductive material via the power supply roller by passing a current of 50 microamperes. Then the paper is statically polarized, and the toner on the drum adheres to the paper by electrostatic attraction. Unlike the conventional corona transfer system, in the transfer belt system, transfer is performed with the paper adhering to the transfer belt completely. Thus, transfer efficiency is stabilized constantly, and a constant transfer output is applied between the leading edge and the trailing edge of the paper. In addition, if no paper is present in the transfer process, the power supply roller output is turned off to reduce the amount of ozone generated. By electrostatic attraction acting between polarization charges on the bottom surface of the paper and the transfer belt, the paper adheres to the transfer belt and separates from the drum along with the toner. If the paper does not separate due to a problem with static absorption or moist paper, the paper will be forcefully separated from the drum by the separation claw in order to prevent paper jams in the cleaner unit. And the paper will separate from the transfer belt where the belt curves. Paper dust and toner adhering to the transfer belt are scraped off by the cleaning brush, which is biased at 300 to 700 volts by a current of 5 microamperes, and the cleaning blade, and then collected into the toner box by the recovery auger. The toner adhering to the cleaning brush is scraped off by the flicker. In the fixing process, the 200 degrees Celsius of the heat roller and the pressure of the rubber roller fix the toner permanently on the paper. The silicone roller and the felt roller are installed to clear toner and paper dust from the heat roller, and the silicone roller and the metal cleaning roller to clean the pressure roller. And there are separation claws to separate the paper from the heat roller and pressure roller. To enhance subsequent cleaning efficiency, lowering the electrical potential of the drum surface allows paper dust and residual toner to be cleared from the drum by the grounded conductive fur brush. The toner adhering to the fur brush is scraped off by the flicker. In the cleaning process, The toner remaining on the drum is scraped off by the main blade and collected by the recovery blade. The collected toner is then stored in the toner box. Finally, to even out the charge on the drum for the next charging step, the light from the discharge LED array, where 16 red LEDs with a wavelength of 616 nanometers are arrayed, illuminates the entire drum, and discharge is performed. That is the copy process. But depending on the drum counter, the development counter, the drum thermistor, and the toner adhesion amount sensor, the following controls are performed for high image reproducibility. As the drum is used, the electrical potential of the drum surface gradually becomes lower. As a countermeasure against this, the charger grid voltage and laser intensity are raised, corresponding to the drum counter. When the drum counter reaches 190,000, which is equal to 400,000 copies for the DP6570, the charger grid voltage is raised by about 4% from the initial, and the laser intensity by about 17%. And in order to fit into the characteristics of the developer material, when the development counter is between 0 and 50,000 for A4 letter, the charger grid voltage is increased by about 8%. Along with that, the laser intensity is increased by about 4%. And furthermore, the developer bias by about 25%. In addition, the rotation speed of the magnetic roller is raised by about 8%, or by 2 bits. Additionally, after the autotoner sensor is adjusted, the autotoner sensor control signal is raised by 7 bits to stabilize an image. The charger grid voltage is varied by the drum thermistor according to the drum counter at between 10 and 50 degrees Celsius, in the range of about 4 to 15%. In addition to these controls, control is performed by the toner adhesion amount sensor in order to maintain image quality corresponding to the actual operating environment and use of the drum and developer material. A 14 by 50 mm halftone pattern is developed on the drum when a pre-run is completed, or when 2,000 copies are made, and then its density is detected by the toner adhesion amount sensor. Thus, by reflecting the result of the density detection throughout the process controls performed by the counters and thermistor, the image can be better maintained. First, we will look at the scanner section. The scanner section is composed of carriages 1 and 2, lens, and CCD board, and is responsible for photovoltaic conversion, signal amplification, AD conversion, shading correction, and peak level detection. In original scanning, light is directed at the original. Then the reflected light is projected to the CCD via the mirrors and lens. And the entire original is scanned by the carriages moving in accordance with the size of the original. The 180-watt halogen lamp is used for illuminating the original and is controlled by an on-off DC switch. Since the CCD can detect minute changes in light intensity, it is necessary to prevent the lamp from flickering. At this time, in order to scan the information on the original is divided both vertically and horizontally in sequence. Then the black part of the original is scanned as information present, and the white part as information absent. In this case, the line scanning direction by the CCD, or the one by the laser, is called the primary scanning. The moving direction of the carriages or paper is called the secondary scanning. The image is divided into tiny dots vertically and horizontally. The density information of the smallest unit for image forming is called a pixel. The smaller the pixel is, the higher the resolution is. So the reproducibility of the image on the original can be increased, but the amount of image information is also increased. Resolution is measured by scanning track density, in other words, the number of scanning lines or pixels per unit length, expressed as lines per millimeter or dots per inch. The CCD is a single-chip photovoltaic conversion device composed of thousands of photosensitive elements of a few square microns arranged in a row. It generates the electrical charges in proportion to light energy and irradiation time. Pitch in the photosensitive element of the CCD corresponds to scanning track density. The CCD in the DP6570 has 7,504 elements for a resolution of 600 dpi. The electrical charges generated in the photosensor area are sent to the transfer area, but due to the slow transfer speed of the CCD, the charges are divided into 4 channels and output in parallel. After being converted into voltage, the electrical charges are shifted according to the transfer clock and sequentially output from the CCD. The voltage generated in the CCD is only several hundred millivolts, so signal amplification is performed using the amplifier to increase it by several volts. 4-channel image data is coupled at the 2 amplifiers respectively. It becomes 2-channel image data and then it is output. When the power is turned on, a white shading standard board is scanned. In order for the output voltage level of the amplifier to fall to a proper level, each signal amplification factor is adjusted. Internal processing of the digital copier is performed with the digital signals 1 or 0. However, since the signal obtained by the CCD is analog, AD conversion is required. AD conversion divides the analog signal into 256 levels. In other words, the digital signal is generated by dividing the analog signal into 256 levels between white and black. And before shading correction, the 2-channel image data is rearranged into the 1-channel serial data. Next, we will talk about shading correction. With the digital copier, since the reflected light is collected by the lens, there should be a difference in the intensities of light reaching the center and the ends of the CCD. Also, the photovoltaic conversion capacities of each element of the CCD are not even. So shading correction compensates for uneven illumination of the image data and for device inconsistencies. Prior to the original scanning, results from scanning the white shading standard board with the exposure lamp turned off are represented as the black data, while the results from scanning the board with the lamp turned on are represented as the white data. Based on these data, correction is made for optimums by each element of the CCD. Next, let's talk about the image processing section. The image processing is performed on the SLG board, the CIS board, and the PLG board. On the SLG board are performed the high-quality image processing, image memory editing, editing processing, gamma correction, and tone processing. Range correction and filtering should be made for high-quality image processing. Range correction corrects the image signal to conform to the density range width of each original. When an original with a high-density background is copied, this function can eliminate the background density and darken light characters. Filtering has 2 functions, the low-pass filter circuit and the high-pass filter circuit. In the low-pass filter circuit, averaging is performed based on the image signals from the pixels around the target pixel. By using it as the image signal of the target pixel, image and electric noises are filtered out, and high-quality reproducibility is provided. In addition, any moire, which theoretically occurs in digital processes, can be reduced. In the high-pass filter circuit, an enhancement operation is performed based on the image signals from the pixels around the target pixel. This is considered as the image signal of the target pixel. Then scanner characteristic correction, such as sharpening the edges of characters, is made. The image memory editing function uses line memory. Various editing functions are possible by controlling the write and read of the line memory. The line memory can store the pixel data of one line for the primary scanning direction and is updated each line. As a result, enlargement and reduction, slant image, mirror image, and so on will be made available in the primary scanning direction. However, changing the carriage scanning rate enables enlargement and reduction in the secondary scanning direction, like an analog copier. In addition, such image editing processes as trimming and masking and negative-positive reversal are performed. Next is gamma correction. The relationship between the original density and the copy density would be more likely to be a solid curve due to the characteristics of the photosensitive drum, toner, and so on. But gamma correction makes the copy density proportional to the original density, with the reverse gamma curve as indicated. Gamma correction enhances reproducibility of the original at every level of gradation. In the tone processing function, the error diffusion method is used. This permits the stable reproducibility of halftones, regardless of the electrophotography method. The error diffusion method can create an image pattern having halftones by controlling the ratio of white and black pixels. Therefore, as an area becomes larger, a larger level of grayscale can be provided. As we can see, the error diffusion method is used because it allows gradation to be maintained as it is with less memory and provides a superfine image. In addition, in the tone processing function, the text mode, the photo mode, and the text photo mode are enabled by changing the slope of the gamma curve, the intensities of the filtering, and the range correction. After tone processing, the image data is sent to the sys board. A wide variety of image editing is performed on the sys board, including memory copying, sort, group, 2-in-1, 4-in-1, page number, annotation, magazine sort, document storage, cover sheet, and sheet insertion. In normal copying, the scanned image data is expanded in the page memory, and the copier enters into printing operation. Simultaneously, this same data is encoded and then stored in the hard disk. From the second set copying, the data stored in the hard disk is decoded and processed in the synchronous mode, where the data is expanded in the page memory for printing. As we can see, the copying speed can be increased by performing scanning and printing concurrently. In the magazine sort mode, 2-in-1 or 4-in-1, and so on, the copier cannot determine a print position until all originals are scanned completely. Then this image data is processed in the sequential mode, where the data is stored in the hard disk and then printed sequentially. Toshiba's original encoding technique, the Rector algorithm, is used for encoding the image data. This technique features a higher encoding ratio and high-speed encoding and decoding than the conventional JBIG method. In this encoding technique, like the JBIG method, once an error occurs, the data cannot be recovered. Before image data from the sys board is sent to the laser exposure scanning section, the smoothing process is performed on the PLG board. If a binary image in a resolution of 600 dpi is printed as it is, especially for printing a slanted and fine line, since there is no continuity between dots, indentations or jaggies will appear on the line. So in the text photo mode and the text mode, the print capability of a resolution of 2400 dpi in primary scanning is utilized for parts automatically recognized as text and lines, not as halftones. And the jaggies can be reduced by adding or deleting fractions of black pixels between adjacent dots of the image data in a resolution of 600 dpi. The smoothing process will make a fine line in the text in image data look much less jagged and will attempt to improve the image quality. And at this time, by controlling the addition of black pixel fractions and by actively reducing them, it is possible to provide finer lines or texts. A process to output dark, fine, and sharp texts or lines is also performed. Finally, we will explain laser exposure scanning. Laser exposure scanning is performed by the laser optical unit and the PLG board. The image signal sent from the image processing section is converted into an optical signal. Then the photosensitive drum is exposed to the optical signal. On the PLG board, an effective image area is specified. A clock signal synchronized with the horizontal synchronizing signal, H-sync, is generated, and the laser drive is controlled. The laser optical unit includes the polygonal mirror motor drive board, or POL board, polygonal unit, 4 laser units, lenses 1 and 2, H-sync detection mirror, H-sync detection board, reflection mirror, slit glass, 3 half mirrors, 4 galvanic mirrors, and cylinder lens. The laser diode being used is an indium gallium aluminum phosphide high power output semiconductor laser, which oscillates in single horizontal mode with an oscillation wavelength of about 685 nanometers. This laser diode is driven by a 5-volt DC power supply, and its optical output is controlled to about 2.5 milliwatts. The laser beam emitted from the laser diode is focused on the drum by the collimator lens, and the laser beam is shaped by the aperture. After the laser beam emitted from each laser diode is reflected by the galvanic mirrors, the laser beam is either passed through or reflected by the half mirrors, and then the drum is irradiated. The 4 laser beams have their absolute positions detected by the beam position sensor contained in the sensor chip. And by adjusting the angle of the galvanic mirror to correct the pitch error between the 4 laser beams, their positions are controlled in the secondary scanning direction so that the pitch becomes 42.3 micrometers. After that, the laser beams are focused by the cylinder lens and then become incidental to the polygonal mirror. The polygonal mirror is rotated by the polygonal mirror motor at 18,608.1 RPM while it is in the standby state and during copying. The laser beam is reflected by the polygonal mirror. This reflected beam moves in synchronization with the rotation of the polygonal mirror. This moving direction is the primary scanning direction. Since the mirror is irradiated with 4 laser beams at the same time, 4 scans are performed for each face of the mirror. Since the polygonal mirror has 8 faces, 32 primary scans are done per rotation of the mirror. And the laser beams reflected by the polygonal mirror become incidental to lenses 1 and 2. Lenses 1 and 2 correct the deviation of the dot pitch on the drum, which is wider at both ends of the scanning line and narrower at the center due to the difference of the optical path. In addition, they correct pyramidal error, in other words, deviation of the laser beams caused by the mirror plane of the polygonal mirror, which is tilted in a perpendicular direction, or correct the shape of the laser beam spot on the drum. At the beginning of the scanning of each face of the polygonal mirror, the 4 laser beams are reflected by the H-sync detection mirror and become incidental to the sensor chip on the H-sync detection board. These incidental beams become the horizontal synchronizing signals on each laser drive board. After the horizontal synchronizing signal is detected, the laser exposure scanning of 4 lines is performed. Then the same signal is detected again. This procedure is repeated. If the signal is not detected, the laser diode will immediately stop driving, and then "Call for service" will be displayed. The sensor chip on the H-sync detection board detects a pitch between 4 laser beams on the drum, as well as a laser beam power. The reflection mirror leads the laser beams that pass through lens 2 to the drum. The slit glass is located where the laser beams are output from each laser optical unit, and it protects the inside of the laser optical unit against dust. The components for the laser optical unit are vulnerable to dust. Especially since the polygonal mirror rotates at a high speed, if any dust hits it, it may scratch the mirror. This would cause defective images. Therefore, never disassemble the laser optical unit in the field. Next, let's talk about the image processing. This chapter will describe the image processing from the original scanning to exposure on the photosensitive drum. The image process consists of the scanner section, image processing section, and laser exposure scanning section. First, the AC circuit and power supply unit. The HTR-SW fuser switch is turned on by inserting the fuser unit. When the power cable is plugged in, AC input is supplied to the upper and lower damp heaters through the breaker and noise filter. When the main switch is turned on, AC input is applied to the power supply unit, one of the two switching regulator circuits is activated, and plus 3.3 volts A to C, plus 5.1 volts B, D, E, H, and I, plus 12 volts B to C, and plus 24 volts F to H for the system main series are output to start up the system. The system main series output provides a power supply to be mainly used for the LGC board, sys board, control panel, ADF, and finisher. The system main series output is the power to be used for the entire copier. It is connected even if the door switch or exit cover switch is off because the front door or exit jam release cover is open. Next, with the exit cover switch turned on, when the door switch is turned on, AC input is supplied to the two heater lamps through the SSR. And this AC input is sent to the lamp regulator board and used as a power supply for an exposure lamp lighting circuit with a DC constant voltage control system. In addition, the other switching regulator circuit is activated, and plus 5 volts A, plus 24 volts A to E, and plus 36 volts A to D for the drive series are output from the AC input. The drive series output provides a power supply to be mainly used for motors, clutches, and laser. For protection against overcurrent, the power supply unit has fuse F2 on the primary side of the system main series and fuse F1 on the primary side of the drive series. On the secondary side, F3 is installed for protection against overcurrent of 24 volts A and 24 volts B, F4 for 24 volts C, F5 for 24 volts D and 24 volts E, F6 for 36 volts A and 36 volts B, F7 for 36 volts C, F8 for 36 volts D, F9 for 24 volts F and 24 volts G, and F10 for 24 volts H. Furthermore, the overcurrent protection and overvoltage protection circuits are provided for each switching regulator to prevent trouble such as damage to the secondary circuit or erroneous operation. Loads for each voltage are as follows. Depending on time specified by code 206 in the 08 setting mode, when the copier is used standalone, the auto power off function is activated, and the main switch can be forcefully turned off by the reset signal from the LGC board. Also, the main switch can be forced off by the reset signal from the LGC board when a malfunction occurs. Next, let's talk about the control block. The control block may be divided into the following three systems: the mechanical control system, the image process system, and the data process system. The mechanical control system is equivalent to the control of conventional analog copiers and is performed by the LGC board. The LGC board has a main CPU to control the entire printer engine, gate array as an I/O port, and PFC CPU to control the paper feed section. The PFC CPU is controlled by the main CPU via the gate array. Furthermore, PROM, NVRAM, and SRAM each are prepared for use with the main CPU. The main CPU communicates with the finisher as well as with the sys and PLG boards, in addition to various analog inputs. The main CPU performs input-output control for these devices. The gate array, controlled by the main CPU, performs input-output control and communicates with the PFC CPU in place of the main CPU, and also outputs various analog reference voltages via the DA converter. The PFC CPU generally controls the components related to the paper feed, including the ADU, LCF, and PFP, as well as the paper feed section of the copier itself. Image processing is performed by the CCD board, SLG board, PLG board, and the page memory sections on the sys board. We will go into detail about the page memory section on the sys board when we talk about the data process system. The CCD board controls CCD driving and image scanning. The CCD board has the ASIC SH drives the CCD, amplifies an image signal scanned by the CCD, and performs AD conversion, data rearrangement, and shading correction. The SLG board has the scanner CPU and ASIC SIPs and controls the scanner and image processing. PROM and SRAM are prepared for use with the scanner CPU, and the CPU controls the SH and SIPs ASICs on the CCD board and SLG board respectively. The scanner CPU also controls the SDV board and the entire scanner, as well as the ADF. The SIPs ASIC on the SLG board is controlled by the scanner CPU and provides various editing processing functions, including memory editing, in addition to the range correction and filtering functions. Furthermore, such functions as gamma correction, image density adjustment, tone processing, and interface control with the page memory section are implemented. The PLG board has the laser CPU and ASIC POPs and controls the laser exposure scanning process. PROM and SRAM are prepared for use with the laser CPU. This CPU controls rotation of the polygonal mirror motor by communication with the main CPU, and the galvanic mirror driver via the DA converter based on a signal from the H-Sync detection board to even the pitches between the 4 laser beams. In addition, the laser CPU controls each laser power evenly via the ASIC POPs. POPs is controlled by the laser CPU and performs the smoothing process, image area control, 4-channel laser drive control, and H-Sync error detection. Data processing control is performed by the sys board. The sys board has the system CPU, the ASIC SDAC for extending functions of the CPU, a gate array, Capella, for the PCI bus interface, HDD controller Piccolo 2, LCD controller, the ASIC DRCM for controlling the page memory, and the LSI Rector for encoding and decoding. NVRAM, VRAM, 8 SDRAMs, and FROM are prepared for use with the system CPU. The system CPU can establish communications with the devices on the PCI bus, including Piccolo 2, SDAC, DRCM, DSI board, and LAN printer board, via the gate array Capella for the PCI bus interface. The system CPU communicates with the main CPU and scanner CPU via the ASIC SDAC for the function expansion and controls the page memory section, control panel, HDD, LAN printer board, and DSI board. The page memory section located on the sys board stores the image data digitized by the SIPs ASIC on the SLG board in units of pages. The page memory section performs editing such as rotation and rearrangement for the stored image data, and then sends them to the POPs ASIC on the PLG board for printing. The page memory section has the ASIC DRCM for controlling the page memory, the LSI Rector for encoding and decoding, 1 megabit SRAM for the rotation line buffer, and 4 8 megabyte DRAMs for the page memory. The ASIC DRCM for controlling the page memory performs address and data control on the page memory section, data permutation in rotation processing, and transfer of the image data between the scanner or laser optical unit and the page memory section via the scanner interface and printer interface. The LSI Rector encodes and decodes image data on the page memory section. The entire control panel is controlled by the key CPU on the DSP board, as well as the system CPU via SDAC. The key CPU controls the reading of the keys and touchscreen panel. In order to show a message on the LCD, first the system CPU requests the EFROM for the data to be displayed and writes this data to the VRAM. The LCD controller reads the data to be displayed from the VRAM and then outputs it to the LCD on the control panel. In this way, display of the LCD is controlled by the LCD controller through the system CPU and the ASIC SDAC for system expansion. And LED illumination is controlled by the LED driver on the DSP board through the system CPU and gate array. The optional LAN printer board or DSI board is connected to the sys board via the MTB board. Next, let's take a look at the flow of image data. During the copy operation, the image data scanned by the CCD undergoes shading correction on SH on the CCD board. Then, after the image processing is applied by SIPs on the SLG board, the image data is sent to DRCM on the sys board. In DRCM, the image data is stored in DRAM for the page memory, while the same image data is encoded by Rector. The encoded data is sent and stored in the hard disk through DRCM, Capella, and Piccolo 2. At the same time, the image data stored in the page memory section is sent to POPs on the PLG board, and then is sent to the 4 LDR boards as 4-channel serial data. Sending the image data from SIPs and storing it in the page memory, encoding the image data, storing the encoded data in the hard disk, and outputting the image data to POPs are performed concurrently. As a result, scanning an original, storing the encoded data, and printing can be performed at 65 copies per minute. From the second set copying, the image data stored in the hard disk is decoded by Rector and then expanded in the page memory section. This image data is sent to the POPs ASIC on the PLG board at 65 copies per minute and then sent to the 4 LDR boards as 4-channel serial data. In printing, the image data passed over the PCI bus via the MTB board is stored in the hard disk. After that, like the copy operation, the image data is sent to POPs on the PLG board and then is sent to the 4 LDR boards as 4-channel serial data. Next, we'll discuss the electrical circuits. We would like to introduce the Toshiba digital copier DP6570 or 5570 and its option MJ1006 or 1007. As for product variations, we have a standalone model, an independently operating digital copier, a multifunctional product, the MFP, which adds LAN printer functions along with the digital copying functions, and there is an integrated input-output device for paper and electronic documents, known as the DSS, or Document Solution System. Since there are a lot of similarities between the DP6570 and DP5570, except in copying speed and PM cycle, unless otherwise specified, we will use the DP6570 as an example when giving you explanations. Also, as for the finishers, the MJ1007 and MJ1006, unless otherwise specified, we will use the MJ1007, which has a saddle stitching function for magazine sorting, as an example. Here we will describe only the standalone type due to the timing of this product's release. First, the cleaner unit. Take off the connector, remove the screw, and detach the drum thermistor. Turn the cam to separate the main blade from the drum. Remove the two screws and draw out the drum shaft. Gently take out the drum from the cleaner unit, taking care not to touch the green part of the drum. Remove the 3 screws and take out the drum front flange. Pull the drum upward. Be sure to apply patting powder on the new drum. And clear the drum counter to 0. Remove the 4 screws and then detach the top cover. Turn over the main blade holding the bracket. Remove the screw and spacer and detach the main blade holding the screw end. Remove the 2 screws and detach the cover with the spring. Remove the E-ring and detach the cam. Turn up the cleaner unit. Slide the separation claw unit toward the front. Pull out the shaft from the rear bushing and take out the unit toward the rear. Remove the 3 screws and pull out the 2 separation claws along with the stopper and the paper guides from the shaft. Pull the shaft knob of the fur brush out toward the front. And then take the fur brush out of the cleaner unit. If the toner box is full, remove the 2 coin screws, open the toner box cover, and then take out the toner box. Mount the cap. The toner box usually becomes full every 100,000 copies. Be sure to instruct the key operator to keep that in mind. Set a new toner box. Close the toner box cover, and then fix it with the 2 coin screws. Finally, let's look at the laser optical unit. Remove the 2 screws and detach the glass holder and the original glass. Shift the carriage to the paper feed side and remove the 2 screws fixing the laser optical unit. Remove the 8 screws and detach the rear cover. Then remove the 2 screws and the left top cover. Unscrew the 8 screws and then slide the indicator unit from its position. Then disconnect the intermediate connector to remove the unit. Disconnect the connector and unscrew the 11 screws. And then detach the lens cover. Disconnect the connector. Remove the screw to detach the cover. And disconnect the connector. Open the exit jam release cover. Remove the 2 screws and detach the upper paper exit cover. Remove the 4 screws, loosen the 11 screws, and detach the slot cover by sliding it down. Disconnect the 4 connectors. Remove the 2 screws and pull out the electrical unit. Unplug the 2 connectors and the intermediate connector and take off the harnesses from the 3 harness clamps. Remove the 2 screws to detach the stay. Then draw out the laser optical unit. At this time, and during installation, be careful not to touch the slit glass. Many precision parts are used in the laser optical unit. Be careful not to cause any shock to the unit. When putting the unit down, the motor should face toward the top. Next, let's look at the drum-related section. Take out the main charger. Detach the grid cover. Push the terminal head of the main charger to unhook the grid. Remove the grid, taking care not to touch the mesh section of the grid with your bare hands. Detach the terminal covers on the front and rear sides. And remove the charger wire. Remove the screw and detach the wire cleaner. Open the exit jam release cover. Unscrew the 2 screws and detach the upper paper exit cover. Unhook the ozone filter holder and withdraw it. Then take out the ozone filter. Next, let's look at the developer unit. Remove the 2 screws and detach the top cover. Tilt the developer unit and completely remove the developer material while turning the gear. Be careful not to get the developer material on the connector. Pour the new developer material evenly. And level it. Then turn the gear with your fingers as indicated by the arrow and rotate the magnetic roller so that the developer material conveys evenly. Securely insert the 4 hooks of the top cover. And fix the cover with the 2 screws. Confirm that the side frame milers on the front and rear are placed between the 2 polyurethane sheets on the top cover and that these are not caught in the top cover. After replacing the developer material, be sure to perform the auto toner sensor adjustment. Enter 201 in the 05 adjustment mode, confirm the sensor adjustment value, and make a note of it. When the auto toner sensor adjustment is finished, the development counter will be reset to 0 automatically. Remove the 2 screws and detach the upper paper feed cover. Remove the screw and detach the filter cover. Withdraw the toner filter. Attach the toner filter so that it is firmly inserted into the case guide. Next is the paper feed section. Remove the 2 screws and detach the LCF knob. Turn the LCF release lever and slide out the LCF, paying full attention not to get your fingers caught. Open the manual feed tray. Snap off the clip. Pull out the shaft pushing down the roller and remove the manual pickup roller. Snap off the clip and then remove the holder arm and manual feed roller. Remove the screw and detach the paper guide. Snap off the clip and pull out the manual separation roller. Next, let's take a look at the transfer belt unit. Withdraw the belt transport unit. Remove the screw and detach the fuser unit. Be aware that the fuser unit is heated. Remove the blue stepped screws on both sides of the belt transport unit. Hold the grips on both sides of the belt transport unit and lift it up to detach it. Remove the two screws and detach the inner cover. Disconnect the two power supply connectors and remove the two ground fixing screws. Snap off the clip at the front and shift the bearing. Remove the two bearing bracket fixing screws at the rear and the two casing fixing screws. Release the front lever and detach the transfer belt unit upwards. To attach the transfer belt unit, be sure to slide the front lever of the transfer belt unit under the cam. And fasten the screws in the following order: the two bearing bracket fixing screws, the casing fixing screws on the rear, and the screws on the front. Rotate the transfer belt support section by 90 degrees and then detach it upwards. Remove the two screws. Partially collapse the drive roller bracket and take out the transfer belt. Please take care not to touch the surface of the belt with your bare hands. Snap off the stop ring. Then remove the holder and spring at the front. Likewise, snap off the stop ring and remove the holder and spring at the rear. Move the power supply roller closer to the front and detach it by pulling out the shaft at the rear. Please do not touch the surface of the power supply roller with your bare hands. Remove the three screws and detach the transfer belt cleaning blade. Please do not touch the edge of the blade with your bare hands. Remove the screw and detach the transport guide. Snap off the stop ring and take out the three gears at the front. Snap off the clip and take off the bushing at the rear. Move the transfer belt cleaning brush closer to the rear and then pull out the front shaft to remove the brush. Next is the fuser unit. Remove the two screws and detach the fuser front cover. Remove the two screws and detach the fuser rear cover. Remove the three screws and detach the fuser cover. Remove the two E-rings at the rear and the two bushings. Remove the shaft bracket and detach the 3-stepped gear. Then shift the 2 bushings at the front. Lift the upper felt roller to remove it. Likewise, remove the upper silicone roller. During installation, please note that the upper felt roller has a black spring and the upper silicone roller has a silver one. Remove the screw at the front and detach the jam release unit. Remove the screw and detach the upper separation claw unit. Remove the 6 upper separation claws by releasing each spring. Disconnect the 2 connectors of the heater lamps and remove the harnesses from the 2 harness clamps. Remove the screw and then detach the front lamp bracket. Take off the harnesses from the 2 harness clamps at the rear and disconnect the 2 lamp connectors. Remove the screw to detach the drawer connector bracket and then remove the screw to detach the rear lamp bracket. Take out the 2 heater lamps, taking care not to touch the lamp surface with your bare hands. When installing the lamps, be sure that the Toshiba mark faces to the front and fit the 2 lamps into the holes of the lamp brackets. Fully loosen the 2 screws securing the pressure spring. Remove the screw to detach the grip bracket. Snap off the stop ring at the front and take out the gear. Remove the 2 screws and remove the bearing. Snap off the stop ring at the rear and detach the timing belt and pulley. Remove the 2 screws to detach the grip bracket on the rear and take out the 2 screws and the bearing. Wrap the heat roller with paper and take it out, being careful not to deform the thermistor. Remove the screw at the front and the rear and open the lower separation claw unit. Detach the lower cleaning roller. Remove the 2 screws and open the lower entrance paper guide. Detach the lower silicone roller. Wrap the pressure roller with paper. And lift up the pressure roller together with the bearings. When installing the pressure roller, make sure the bearings are securely set on the pressure levers. When installing the heat and pressure rollers, fully tighten the screws of the pressure springs. If paper often wrinkles or jams, the 2 screws securing the entrance paper guide should be moved into the oblong holes. If paper wrinkles, move it upward. If thick paper needs to be fed smoothly, move it downward. Make these adjustments while referring to the marks. Next is the PFP. Take out all cassettes and the LCF. Remove the 2 screws and take out the upper PFP paper feed unit. Then remove the middle and lower PFP paper feed units in the same way. Though the upper and middle PFP paper feed units have the same parts, the lower one is not equipped with the aligning roller and paper stop switch. Please do not confuse it with the upper and middle PFP paper feed units. We will take the upper PFP paper feed unit as an example. Press the protrusion of the arm and detach the PFP pickup roller from the arm and the belt. Snap off the 5 E-rings and pull out the pulley and one-way from the PFP pickup roller. Unscrew the 2 screws to detach the pre-roller guide. Snap off the clip and detach the PFP separation roller. Snap off the clip and detach the PFP feed roller. Replace the PFP pickup, feed, and separation rollers of the middle and lower PFP paper feed units in the same manner as the upper PFP paper feed unit. Next is the RADF. Take off the 2 screws and the original feed tray. Remove the 8 screws and the rear cover. Unscrew the 2 screws to detach the left top cover. This bracket can be removed by taking out the 3 screws in mass production products. Take out the 2 connectors and the ground fixing screw. Detach the harnesses from the harness clamp and remove the harness band. Remove the 2 screws and take out the ADF unit. Open the jam release cover. Remove the 2 screws and detach the separation unit. Remove the ADF separation pad from the bracket. Snap off the 2 clips. And detach the transport unit, tilting it toward you. Loosen the screw fixing the belt tension bracket. Partially collapse the belt tension brackets and then take out the ADF transport belt. During assembly, install the transport belt with its edges inside the side frames. Remove the 3 screws and detach the maintenance cover. Disconnect the 4 connectors from the PC board. Open the jam release cover and loosen the screw. Remove the 6 screws. Shift the harness guide and remove the timing belt. Then detach the paper feed unit. Please be aware that the length and type of these screws are not all the same. Remove the 4 screws. Detach the entrance guide while lifting the empty sensor upwards. Remove the E-ring and the bushing at the front. Snap off the stop ring and and pull out the ADF pickup roller from the shaft. Remove the E-ring, the spring, and the bushing at the front. Snap off the stop ring and pull out the ADF feed roller from the shaft. Next, let's look at the LCF. After lowering the elevator tray, turn off the main switch. Open the LCF door and take out the paper. Snap off the clip and pull out the weight. Pull out the shaft to detach the LCF pickup roller. Remove the 2 screws to detach the paper guide. Snap off the clip and pull out the LCF feed roller. Likewise, snap off the clip and pull out the LCF separation roller. Next, we'll explain disassembly and replacement. We'll mainly focus on disassembly for the parts which require replacement in periodic maintenance. First, make a positional adjustment of carriages 1 and 2. Move carriages 1 and 2 toward the paper feed side so that the position of carriages 1 and 2 is aligning with the frame screw holes, and loosen the front and rear screws fastening carriage 1 to the wires. On the front side, loosen the 2 front screws fastening carriage 2 to the wire. Move carriages 1 and 2 to the paper feed side. Return carriage 1 a little, and with carriage 2 securely in contact with the paper feed side frame, tighten the 2 wire fixing screws. In this state, with carriage 1 in contact with the paper feed side frame, secure it to the wire with 1 screw each on the front and rear. Next is the adjustment of mirrors and lens. We'll explain how to adjust the lens reproduction ratio. Make this adjustment when detaching the lens unit for replacement. 2 lens adjustment jigs are required. Before making this adjustment, please confirm that the scanner primary scanning reproduction ratio is correct. Place the scale on the original glass in the primary scanning direction. And then make an A4 or letter actual size copy. Compare the actual scale with the copied one. When an adjustment needs to be made, remove the 2 screws and detach the glass holder and original glass. Then remove the connector and 11 screws to detach the lens cover, and remove the 2 screws to detach the lens shield bracket. Insert the 2 lens adjustment jigs into the oblong holes on the lens base. When making an adjustment for the first time, we recommend tapping the holes with a 3 mm tapping screw so that it will become easier to set the jigs. Loosen the 2 lens unit fixing screws and then make a positional adjustment of the lens unit referring to the marks. If the copied scale is smaller, move the lens unit toward the paper feed side. And if it is larger, move it toward the paper exit side. Move the lens unit in the distance shown on this table, depending on the reproduction ratio error. Secure the 2 screws of the lens unit. And then remove the 2 lens adjustment jigs. Reassemble the copier and make a copy to check the lens reproduction ratio. After the adjustment, you should adjust the CCD primary scanning deviation, which we'll talk about later. Next, adjust image distortion. The screw lock paint is required for the adjustment. Remove the original glass. Rotate the Mirror 2 adjustment screw and eliminate distortion in one direction. Then turn the Mirror 1 adjustment screw and restore the normal image. After the adjustment, make sure that no dust adheres to the mirror or shading standard board. And be sure to apply the screw lock paint. Next, adjust image inclination. To make an adjustment easier, remove the glass holder and slide the original glass toward the paper feed side. Adjust image inclination by loosening the screw at the front and moving the original scale. Next is the adjustment of the high voltage transformer output. For adjustment, the door switch jig and a digital voltmeter with an input resistance of 10 megaohms or higher are required. Detach the developer unit and then check and adjust the main charger output. Set the door switch jig. Set the voltmeter at the 1000 volt DC range. Connect the minus common terminal of the digital voltmeter to the copier frame and set the plus terminal on the charger case. Enter the 05 adjustment mode. Key in 210, press the start key, check that 0 is displayed, and press the start key again, in that order. The main charger grid voltage will be output in the text photo mode. Make sure the voltmeter indicates minus 720 volts plus or minus 5 volts. If the voltage is outside that range, adjust the voltage using the up and down icons. Then store it in the memory using the set icon or interrupt key. To adjust the main charger grid voltage in the text mode, key in 210, press the start key, key in 1, and press the start key again in that order. Then enter the same adjustment value as in the text photo mode using the digital keys. And store it in the memory using the set icon or interrupt key. Likewise, to adjust the main charger grid voltage in the photo mode, key in 210, press the start key, key in 2, and press the start key again, in that order. Then enter the same adjustment value as in the text photo mode using the digital keys. And store it in the memory using the set icon or interrupt key. To adjust the main charger grid voltage in the printer mode, key in 212 and press the start key. Then enter the same adjustment value as in the text photo mode using the digital keys. And store it in the memory using the set icon or interrupt key. Finally, check and adjust the developer bias output. Attach the developer unit to the copier. And then plug in its connector. Connect the minus common terminal of the voltmeter to the frame ground and the plus terminal to the magnetic roller shaft. In the 05 adjustment mode, key in 205, press the Start key. Check that 0 is displayed and press the Start key again. Then check and adjust the developer bias High 1 in the text photo mode. In order that the voltmeter indicates minus 387 volts plus or minus 5 volts. Make adjustments using the up and down icons. And store the value in the memory using the set icon or interrupt key. To adjust the developer bias High 1 in the text mode, key in 205, press the Start key, key in 1, and press the Start key again in that order. Then enter the same adjustment value as in the text photo mode using the digital keys. And store it in the memory using the set icon or interrupt key. Likewise, to adjust the developer bias High 1 in the photo mode, key in 205, press the Start key, key in 2, and press the Start key again in that order. Then enter the same adjustment value as in the text photo mode using the digital keys. And store it in the memory using the set key or interrupt key. Also, to adjust the developer bias High 1 in the printer mode, key in 203 and press the Start key. Then enter the same adjustment value as in the text photo mode using the digital keys. And store it in the memory using the set icon or interrupt key. To adjust the developer bias High 2 in all modes, key in 207 and press the Start key. Then enter the same adjustment value as in the text photo mode using up and down icons. And store it in the memory using the set icon or interrupt key. Finally, to adjust the developer bias High 3 in all modes, key in 216 and press the Start key. In order that the voltmeter indicates minus 452 volts plus or minus 5 volts, make adjustments using the up and down icons. And store the value in the memory using the set icon or interrupt key. Next is the print image adjustment. The adjustment of the print image requires a scale. Adjust the aligning value, printer unit, and scanner unit in that order. First, adjust the aligning value. For adjustment, use codes 450 to 458 in the 05 adjustment mode. Their details are shown in this table. Next, adjust the printer unit. For adjusting the printer unit, the adjustment order is further determined as shown here. First of all, adjust the printer primary scanning reproduction ratio. In the 05 adjustment mode, select A4 or letter from the LCF and press the 1 and Energy Saver key to perform test printing. To set the distance to 200 millimeters plus or minus 0.5 millimeters between the first line and the 21st line from the front on the printed test sheet, adjust the value of code 401. Next, adjust the laser start position. To set the distance between the test pattern front edge and the sixth line to 52 millimeters plus or minus 0.5 millimeters, adjust the value of code 411 and then adjust code 410. Then adjust the printer's secondary scanning reproduction ratio. The speed of the transfer belt is adjusted. Select an A3 or ledger size, press 1, and then the Energy Saver key to make a test print. To set the distance to 200 millimeters plus or minus 0.5 millimeters between the 5th line and the 25th line from the leading edge of the test print paper, adjust the value of code 488. Next, adjust the registration. In the 05 adjustment mode, key in 443 and then press the Start key to check the current adjustment value. Then press the Set icon or Interrupt key. Select the LCF and press 1, and then the Energy Saver key to make a test print. To set the distance between the leading edge and the sixth line to 52 millimeters plus or minus 0.5 millimeters, adjust the value of code 443. Then adjust the registration of the PFP, sheet bypass, and ADU in that order by using codes 444, 442, and 445 respectively. Select A3 or ledger size and check the registrations of the middle PFP paper feed unit and sheet bypass. Next, adjust the scanner unit. The order of adjusting the scanner unit is further determined as shown. First, adjust the scanner primary scanning reproduction ratio. Align the scale with the left side original scale. In the 05 adjustment mode, select A4 or letter size, and then press the Energy Saver key to make an actual size copy. To set the distance to 200 millimeters plus or minus 0.5 millimeters between positions of 10 millimeters and 210 millimeters on the copied scale, adjust the value of code 405. Then adjust the CCD primary scanning deviation. Align the side of the scale with the original scale, and align the leading edge of the scale with the line indicating A3 or ledger size close to the rear of the original scale. And make an A4 or letter actual size copy. To set the distance to 100 millimeters plus or minus 1 millimeter between the paper front edge and a position of 100 millimeters on the copied scale, adjust the value of code 306. Then adjust the scanner's secondary scanning reproduction ratio. Align the scale with the original scale, and make an A3 or ledger actual size copy. To set the distance to 200 millimeters plus or minus 0.5 millimeters between positions of 10 millimeters and 210 millimeters on the copied scale, adjust the value of code 340. Then adjust the scanner's secondary scanning deviation. In the 05 adjustment mode, set the adjustment value to 0 in code 430. Align the scale with the original scale. And make an A3 or ledger copy at 400%. In order for the copy of the scale to begin at 2 millimeters plus or minus 0.5 millimeters, adjust the value of code 305. Next, adjust the top margin. With the ADF open, make an A4 or letter actual size copy. In order for the blank space at the leading edge of the copy to be 3 millimeters plus or minus 0.5 millimeters, adjust the value of code 430. Next, adjust the right margin. With the ADF open, make an A4 or letter actual size copy. In order for the blank space at the front of the copy to be 2 millimeters plus or minus 0.5 millimeters, adjust the value of code 432. Finally, adjust the bottom margin. With the ADF open, make an A4 or letter actual size copy. In order for the blank space at the trailing edge of the copy to be 2 millimeters plus or minus 0.5 millimeters, adjust the value of code 433. For the adjustments made so far, the codes and their affected images are summarized as shown. Be sure to observe the adjustment order for each adjustment explained so far. Now we'll explain other image adjustments. First is the automatic gamma adjustment. Be sure to make a copy and perform the automatic gamma adjustment if necessary after replacing the exposure lamp, standard shading board, lens unit, or laser optical unit, or after replacing or adjusting the following parts. In the 05 adjustment mode, select A3 or ledger paper size. Press 2 and then the Energy Saver key, and the gradation pattern will be printed out. Place the printed gradation pattern on the original glass with the dark density side of the gradation pattern facing the original scale side. Key in 580 and press the Start key. And automatic adjustment will be performed. The automatic adjustment completes when the message Test Mode A is displayed. If any error occurs in the adjustment, press the Clear key to clear the error. Then check the position, direction, and skew of the gradation pattern. and re-perform the automatic adjustment. Next, adjust the image density. This is equivalent to the exposure adjustment of an analog copier. These codes will be used for adjustments. Next, adjust the sharpness. These codes are used to adjust the sharpness of the image. Please note that the 1 series, 1, 11, 21, and so on, gives valid adjustment values for the text photo mode. The 2 series, 2, 12, 22, and so on, for the photo mode, and the 3 series, 3, 13, 23, and so on, for the text mode. Finally, adjust the gamma slope correction. Make adjustments using these codes. If a smaller adjustment value is set, the gamma slope and image will become as shown here. On the other hand, if a larger adjustment value is set, the gamma slope and image will become as shown here. Next, adjust the side deviation. First is an adjustment for sheet bypass side deviation. Loosen the screw. If an image deviates toward the front, move the manual feed tray toward the front. If an image deviates toward the rear, move the tray toward the rear. Next, adjust cassette side deviation. Pull out the cassette. Loosen the screw and adjust the position of the cassette guide in the same manner as the sheet bypass feeding. Next, adjust LCF side deviation. Disconnect the 2 connectors. Unscrew the 2 screws. And slide the side guides toward the ends. Take out the manual feed tray unit by pressing the pickup roller. Remove the 2 screws fixing the side guide at the front. And temporarily tighten them in the oblong holes next to their original positions on the side guide. Adjust the position of the front side guide. Also, move the 2 screws fixing the rear side guide and shift the side guide to the same distance as the front. Next, adjust the stack guide stop position. This is an adjustment of side deviation for duplex copying. After stacking paper in the ADU, check that the gap between the side guide and the paper is 0.5 millimeters to 1.5 millimeters. If it deviates, loosen the screw at the rear of the stack guide. And then make an adjustment by rotating the adjustment cam to move the side switch bracket position referring to the scale. And then check the gap between the side guide and the paper. If you still see side deviation even after adjusting the stack guide stop position, please make an adjustment of the ADU side deviation. Loosen the 2 screws fixing the stack guide. If an image deviates toward the front, move the stack guide toward the front. On the other hand, if it deviates toward the rear side, move it toward the rear. Now we'll explain the list print mode. The list print mode allows you to print out a list of the setting values and information for the 05 adjustment mode, 08 setting mode, and access ID code. While pressing 9 and the start key at the same time, turn on the main switch. Key in 101 and press the start key. And the lists of the 05 adjustment mode will be printed out. Key in 102 and press the Start key. And the lists of the 08 setting mode will be printed out. Likewise, key in 201 and press the Start key. And the list of the Access ID codes will be printed out. Finally, we'll talk about the firmware version up mode by downloading from a PC using FTP, File Transfer Protocol. As for system configuration, a PC with Windows 95, virtual modem, FTP server tools, for example, War FTP Daemon, the firmware data to be downloaded, and a serial cable are required. First, set up the PC for network use. Setting the virtual modem is required to perform dial-up networking. The virtual modem can be downloaded from the website shown here. Save the downloaded virtual modem file as directconnection.inf on a floppy disk or a hard disk in the PC. Click Start, choose Settings, and click Control Panel. Choose Modem, click the Add button to open the Install New Modem wizard. Choose Other, and click Next. Check Don't Detect My Modem, I will select it from a list, and click Next. Click Have Disk, choose the folder where the downloaded file is stored. Choose Direct Connection and click Next. Choose Communications Port COM1 and click Next. Click Finish and then installation of the virtual modem will be completed. Finally, click Close. Next, set up the dial-up networking. Double-click Network in Control Panel. In the Configuration tab, confirm that Dial-up Adapter and TCP/IP appear. If Dial-up Adapter does not appear, click the Add button. Choose Adapter from the Select Network Computer Type box. Choose Microsoft from the Manufacturer's List box. And choose Dial-up Adapter from the Network Adapter List box. Click OK and the TCP/IP protocol with Dial-up Adapter will be set up automatically. Next, the new connection settings. Double-click My Computer if the dial-up networking icon does not appear. Open Add Remove Programs in Control Panel. Click the Windows Setup tab, check Communications, and click OK. Dial-up networking will be installed. Double-click Dial-up Networking and make new connection. Type in a name, for example, My Connection, in Type a name for the computer you are dialing. Choose Direct Connection in Select a Modem and click the Configure button. In the General tab, specify 115,200 as maximum speed. And check Only connect at this speed. Click the Connection tab, confirm that no items are checked off in Call Preferences, and click the Advanced button. Confirm that no items are checked off in the Advanced Connection Settings dialog box and click OK. When the Make New Connection dialog box appears, click the Next button. Enter #39 in telephone number. And click the Next button. Click the Finish button and the setting of Make New Connection will be completed. Next is installation of the FTP server. For the FTP server, the freeware War FTP Daemon version 1.65 is required. This software can be downloaded from the website shown here. Create an FTP server folder in the PC, and then download Ward 165exe into it. Double-click the downloaded file, and the file will be decoded automatically. Execute setup.exe, and one of the files is decoded. Then store the setup files into Program Files. Create a WebShare folder on the PC, and in it create an FTP root folder. This folder is used to store the firmware data to be sent to the copier. Click Start, select Programs, and click War FTP Daemon to start War FTPD.exe in the War FTPD folder. Click Properties, select Security, and click Edit User. And then click the Add button. And be sure to type in DPPC in New Name. Be sure to enter DPPC in both New Password and Verify Password. And then click the OK button. Choose DPPC, click the File Access tab, and click the Add button. Double-click WebShare and FTP root, and then click the OK button. Change the check marks for Read, Write, Delete, and Execute from gray to black. In addition, check Root, Home, and Recursive. Change the check marks for List, Create, and Remove from gray to black. And click Apply and then OK. Now you're ready to download the firmware. Finally, we'll explain the firmware version up mode. Please confirm that there are 6 files contained in the FTP root folder in the PC as shown here. These are the files in the folder. Remove the cover from the copier and connect the copier to the PC using a cross-type serial cable. While pressing 3 and 9 at the same time, turn on the main switch. Click Start, select Programs, and click War FTP Daemon. Then switch the FTP server online from offline. Double-click My Computer. Double-click Dial-Up Networking. And double-click My Connection. Enter #39 in phone number and click Connect. If serial communication is established successfully, this dialog box will appear and indicate that the PC is connected to the copier. Then the control panel of the copier will show this. At this point, press the Help or Info key and you can confirm the current ROM version. Key in numeric values indicating data to be rewritten using the digital keys and the # using the interrupt key. Refer to this list. Press the Start key and start downloading. Please do not turn off the PC or copier and do not disconnect the cable. Otherwise, EFROM data will be corrupted, and as a result, the EFROM will need to be replaced. If #1 to #3 are keyed in, this will be shown. After that, turn off the main switch. If 1 to 6 are keyed in, this will be shown. If you would like to continue downloading other items, please follow the same procedure mentioned so far. If you would like to finish downloading, press the Clear key and turn off the main switch. Click Cancel in the Re-establish Connection dialog box to exit the firmware version up mode. That completes our explanation of major adjustments. Now let's take a look at major adjustments. We'll omit the adjustments we explained in the Unpacking and Setup chapter. Now we'll talk about periodic maintenance. Periodic maintenance includes such tasks as cleaning and lubrication of the copier for every 400,000 copies for the DP6570 or 340,000 copies for the DP5570, and periodic replacement of supplies and parts. First, we'll explain the parts to be cleaned. Symbol A means cleaning with a cloth moistened with alcohol. And the circle symbol means cleaning with a soft cloth or soft pad. The following are the parts to be cleaned. Be sure to connect the ground lead to the cleaner unit before you clean it to prevent damaging the toner adhesion amount sensor. The optional finisher needs to be cleaned as follows, depending on the timing of the periodic maintenance of the copier. Next are the lubrication points. Symbol AV means lubrication with Alvania No. 2 grease. Symbol S means lubrication with silicone oil. Symbol W means lubrication with white grease. Symbol L means lubrication with Launa 40 oil. Finally, we'll explain the supplies and parts to be replaced. The number on the upper left of the screen represents the copy cycle in which a part needs replacing. K stands for times 1,000 copies. Main blade. Toner box. Separation clause. Fur brush. Drum. Ozone filter. Main charger wire. Charger wire cleaner. Grid. Developer material. Toner filter. Manual pickup roller. Manual feed roller. Manual separation roller. Transfer belt. Transfer belt power supply roller. Transfer belt cleaning brush. Transfer belt cleaning blade. Heat roller. Pressure roller. Upper silicone roller. Upper felt roller. Lower silicone roller. Lower cleaning roller. Upper separation clause. PFP pickup rollers. PFP feed rollers. PFP separation rollers. ADF pickup roller. ADF feed roller. ADF separation pad. ADF transport belt. LCF pickup roller. LCF feed roller. LCF separation roller. This completes our description of the Toshiba DP6570 or 5570 digital copier and optional MJ1006 two-bin finisher or MJ1007 finisher with the saddle stitcher. It is essential that you have a thorough understanding of the copier and its options in order to ensure that they perform reliably and efficiently. And if called upon, you should be able to provide the kind of expert advice and servicing your customers expect and deserve. To this end, we urge you to study the service manual and attend your local training programs. Remember, no matter how good a product is, it's only as good as the people who support it.